Hey, this is getting near the end of this unit here. We got nominal values and tolerance. So we did precision and uncertainty, which was more about the tools than it was anything else. This one here, when I'm talking about nominal values and tolerance, it's more about what's requested or what's acceptable when you need something. Okay, so it's not about the tool, it's more about the object that's being built or purchased or whatever. So nominal value is exactly what the definition I got written out here is: the target size of an item you want. So it's like the exact size you want to make an item that you want to buy or that you're going to build or something like that you don't have yet. Okay, tolerance is the amount that a measurement is allowed to vary. So it's the combined uncertainty below the nominal value and the uncertainty above the nominal value. So I like to use max and min when I talk about tolerance, because the maximum or minimum measurements that a measure is allowed to be, right? So the highest a measurement can be and the lowest a measurement can be, and it be acceptable. So the difference between your max and your min is the tolerance, and that's how I think of tolerance. So the definition of tolerance, the total amount that a measurement is allowed to vary. Think about that. That's the difference between the biggest size is allowed to be and the small size allowed to be. I like to think about shoe sizes. So what size of shoe are you? Let's for instance say you're a size 9, but you try on a size 9.5 and it fits. Okay, that's acceptable. 8.5's a little bit small, but I can get away with it. So maybe your tolerance is one shoe size. Your nominal, your perfect size is a size 9, right? But you can vary a half size. Now, you might also be that person who says, I like my shoes super tight. So an 8.5 is your perfect size. You can't go any lower, though. But you can wear a size 9.5. So your tolerance is still one shoe size, but it just, your nominal size is a different way of looking at it. We'll get into that later on. Okay, so nominal size, perfect size, tolerances, and the difference between the maximum and the minimum that you can tolerate. So let's look at this. So related to shoe size, I got pants here. Clothing companies allow for a certain tolerance when making products. Men's pants are sold in the whole inch size by their waist measurement. So if you have a 34-inch waist, that's the size of pants you buy. The company allows for an uncertainty of plus or minus a quarter inch when they label their products. So you buy a size 34 pants, you might not actually be getting 34-inch waist. It might be a little bit smaller, but it might be a little bit bigger. So what are the max and min size these pants going to be? So let's assume size 34. Let's use size 34 because I didn't even write that down. So maximum would be 34 and a quarter inches. And the minimum that these pants would be acceptable, that the company would still label them as a 34, would be a quarter inch smaller. So 33 and a quarter, or if you went to your calculator and did 34 minus 0.25, you get 33.75 inches. So there's the max and the min. So what is the tolerance for this? Well, the difference between the two, or both halves of the uncertainty, a quarter inch bigger and a quarter inch smaller, is a half inch. Okay? So there is your tolerance right there. A lot of people mess this up and they think this is the tolerance, but that's usually half of the tolerance when you see plus or minus. Okay? So it's a half of an inch is your tolerance, the difference between your maximum and your minimum. So again, you can put this max in your calculator minus the minimum in your calculator, and it's all good. Okay, next example. You could put it on pause and finish writing that down. Cam is, look at this is a good question for seeing where this comes into when you go into trade school, mechanics, industrial mechanic, diesel mechanic, heavy duty mechanic. Machinists use this all the time. Cam is looking at a machining drawing that has a tolerance of 0.2 inches and a nominal value of 0.5 inches. What is the acceptable range of measurements? So let's think about this, and we'll maybe write this down right now. So his nominal value is 0.5 inches. It says the tolerance is 0.2 inches. So that means we can go up or down, not 0.2, but half of that, 0.1, because remember, we can go to our max, which would be 0.6 inches, or we can go down 0.1, which is 0.4 inches. And that difference is our 0.2 inches, or our tolerance, correct? So you can see the acceptable range of our measurements. So, I mean, it's not real easy right now, but this is one way of writing our measurements, and it's nominal value plus or minus half of the tolerance. So we'll see that at the end of this. I'll put all the different ways we can write it down. It doesn't matter which way you write it down, it's just that's one of the ways. Okay, so next example. Jim works in an automotive repair shop. A manufacturer that supplies spark plugs says the spark plug gap should be between 0.048 inch and 0.052 inch. What are the following? So the tolerance. So this is my minimum spark plug gap, and this is the maximum spark plug gap. So I hope that don't worry about the spark plug thing, okay? This is just one example that comes up. So the difference between max and min, so when I subtract those two, I get a difference of 0.004 inches. And the nominal value, the easiest way to think about your nominal value is the middle of your min and max. Now, it's not always that way, okay, because there's sometimes people can accept, like I said about shoe size. You might be a 9, but you like your shoes fitting tight, and that's to you your nominal value. So I look at it that way. But generally, we look at the middle, and it's 0.050 inches. So there's your nominal value. There is your tolerance right there. Okay? So pretty easy question there if you understand now what tolerance is and what max and min is and nominal value. So the next thing we're going to do is I'm going to just show you, and you can write down all the different ways we can do it, and maybe I'll throw in an example on how to write this stuff. So let's use an example here of a nominal value of, let's say, 8 centimeters, and we have a tolerance of 1 centimeter. And we'll use this and write these out. Okay, so for instance, the first way of writing this out, it could look like this. 8 centimeters plus 0.5 centimeters minus 0.5 centimeters. So you could see it like that. That's how that could be written out. The next thing you could look at is it could look like this. 8.5 centimeters and 7.5 centimeters. Just your max over your min, just like that. That's another way of seeing this stuff written out. The nominal value, so 8 centimeters plus or minus 0.5 centimeters. So another way of writing it out, all meaning the same thing. Now, these are the rare ones, but they appear every once in a while. So instead of putting your nominal value down, a person puts their maximum because it's what they want, right? So they can say 9 centimeters. Or sorry, not 9. Look at me making it. So 8.5 centimeters was our maximum, plus 0 minus 1 centimeter. right? So that's another way. Maybe it's the other way, minimum. So 7.5 centimeters minus 0, saying you can't go any more down, but plus your 1 centimeter. So there's 5 different ways that you might see these things written out. So when I flash back here, and you can pause and finish writing these down, but you can see here on this question, I wrote it out nominal value plus or minus half the tolerance. Okay, this one here I did a max over a minimum. They're kind of interchangeable. Okay, but they all reference the same thing. Okay.